In this lecture, you'll put a lot of what you've been learning to practice. We're going to create the team dashboard in Power BI, and to do this we'll incorporate data sourcing, statistics, design, and of course visualization. After this lecture, you'll have your first hockey analytics dashboard.
Throughout this lecture, you'll learn that the design process involves a systematic approach to creating your dashboard. That is, it begins with identifying the objectives and goals of the dashboard, such as tracking player performance or analyzing team statistics. At this stage, you'll also want to be thinking through the key metrics and data that need to be included. The data source review portion of the lecture emphasizes the importance of selecting reliable and comprehensive data sources for the dashboard. We've covered off on a lot of this already, so we won't go into too much depth other than to review the high-level data architecture and source of the data we'll use for the team performance dashboard. The actual design of the dashboard is a crucial and fun part of the process. It focuses on creating a visually appealing and user-friendly layout that effectively presents the desired information and choosing the types of chart, graphs, and tables that will present the information in the best way. Now, you really have to be thinking about your audience here. That is, who will be consuming your dashboard. If the audience is you, then you may not want to spend a lot of time in a design process. But understanding the process at a high level can be useful, especially if you want to share your dashboards with a broader, more professional audience. The final section of this lecture will walk through final creation of the team performance dashboard, which provides an overview of a team's statistics and performance metrics. We hope you'll see this as a culmination of a lot of the learnings in this course.
In this section, we'll walk you through some steps to help you create a well-designed report. Before we do that, though, it's helpful to get a sense for what a good dashboard looks like as compared to a bad dashboard. Macmillan.com has some great examples of good and bad dashboards. So let's take a look at a couple of examples. Let's look at a bad design first. This is a London City dashboard, and there's a lot going on here. The design is busy. It's cluttered. There are a lot of different colors in the report, and it's difficult to navigate. Data arranged in a report should tell an intelligible story. It's very difficult to understand what the story is here. When we look at a good example, you can see the difference right away. There's a clean design. There's a good use of summary cards at the top of the report. There is a good color contrast. The report is not cluttered, and it naturally moves from summary to detail. As you work through this lecture, be sure to think about how you can create a report that also has good color contrast, is structured well, and most importantly tells a story.
While we'll focus on a team performance dashboard, there are many different types of dashboards that you can create. The first two you will obviously be familiar with, but the others may be new to you. Player performance dashboard. This dashboard could display individual player performance, including stats like goals, assists, shots, plus-minus, and ice time. It could allow users to filter by team, position, and time period, and include visualizations like line charts and tables. Team performance dashboard. This dashboard could display team performance, including stats like wins, losses, goals scored, goals allowed, power play percentage, and penalty kill percentage. It could allow users to filter by team, division, conference, and time period, and include visualizations like bar charts and pie charts. Draft strategy dashboard. This dashboard could help users prepare for their fantasy hockey drafts by displaying rankings, projections, and ADP, average draft position data, for players. It could allow users to filter by position, scoring format, and draft order, and include visualizations like scatter charts and heat maps. Trade analysis dashboard. This dashboard could help users analyze potential trades by displaying performance data for players and teams involved in the trade. It could include visualizations like line charts, scatter charts, and tables, and allow users to compare multiple trade scenarios. Goalie analysis dashboard. This dashboard could display performance data for goalies, including stats like save percentage, goals against average, and shutouts. It could allow users to filter by team, time period, and opponent, and include visualizations like bar charts and heat maps. League standings dashboard. This dashboard could display the current standings for a fantasy hockey league, including wins, losses, and points. It could allow users to filter by team and time period and include visualizations like tables and bar charts. Injury Tracker Dashboard. This dashboard could track player injuries and display information like expected return dates and impact on fantasy performance. It could include visualizations like tables and line charts and allow users to filter by team and injury type. Player Comparison Dashboard. This dashboard could help users compare multiple players and display performance data side by side. It could include visualizations like scatter charts and tables and allow users to filter by position, team, and time period. Waiver Wire Dashboard. This dashboard could display available players on the waiver wire and their performance data. It could include visualizations like tables and bar charts and allow users to filter by position, team, and time period. Playoff Tracker Dashboard. This dashboard could track the playoff picture for a fantasy hockey league, including projected standings, potential matchups, and remaining schedules. It could include visualizations like tables and line charts and allow users to filter by team and time period. There are several steps to creating an effective and informative dashboard. The first step is identifying the purpose of the dashboard. This involves determining the specific goals and objectives of the dashboard, such as tracking player performance, analyzing team statistics, or evaluating game outcomes. By clarifying the purpose, you establish a clear direction for the design process. Next, you choose the appropriate data sources. This step involves researching and evaluating various data providers, such as official league statistics, sports analytics companies, or APIs. Selecting reliable and comprehensive data sources ensures accurate and relevant information for the dashboard. For our dashboard, we've already covered the data source, which is mysportsfeeds.com. Once the data sources have been retrieved, you clean and transform the data. This step involves removing any inconsistencies, errors, or missing values from the dataset. Additionally, data may need to be transformed or aggregated to make it suitable for the desired analyses and visualizations. The normalization for our project was nested within the Python code. Designing the layout of the dashboard is the next step, which involves organizing the visual elements, such as charts, graphs, and tables, in a logical and intuitive manner. The layout should facilitate easy navigation and understanding of the information presented. To design the layout, you can sketch it out on paper, use a tool, or jump right into Power BI and design the layout there. After you've designed a layout, you need to create effective visualizations. This involves selecting appropriate chart types and visualization techniques to represent the data accurately. Visualizations should be visually appealing and support the objectives of the dashboard. Depending on the type of data and what you're trying to show with that data, you would select different visualizations. You'll then want to add filters and interactions to enhance the user experience and enable deeper analysis. Filters allow users to focus on specific aspects of the data, while interactions provide dynamic and customizable views of the information. And finally, you need to test and refine the dashboard. This involves testing to see if the visualizations work as expected, gathering feedback from potential users if needed, identifying areas for improvement, and making necessary adjustments to enhance usability and functionality. The purpose of our team performance dashboard is to create a view that can help you track key performance metrics that help you make key decisions. Admittedly, it's a little fuzzy, but as you create more dashboards, the goals and purpose of them will get more specific. To build the team performance dashboard, we'll use several statistics. These statistics can help you understand how a team is performing in different areas and identify strengths and weaknesses. Total points, wins and losses, power play percentage, penalty kill percentage, shots for and shots against, goals for, and goals against. Each of these can be described in more detail as follows. Total points. The total count of points from the beginning of the season to the latest point in the season. Wins and losses. This is a basic but important statistic that measures a team's overall performance by comparing the count of wins versus the count of losses. It can also be represented through win percentage. Power play percentage. This statistic measures how successful a team is on the power play. It can be displayed as a percentage of power play goals scored per power play opportunities. Penalty kill percentage. This statistic measures how successful a team is at killing penalties. It can be displayed as a percentage of penalties killed per penalty kill opportunities. Shots for and shots against. This statistic measures how many shots a team has taken and how many shots they've allowed. It can help users understand how well a team is controlling possession and generating scoring chances. Goals for and goals against. This statistic measures how many goals a team has scored and how many goals they've allowed. It can help users understand how strong a team is offensively and defensively. These statistics can be displayed in various visualizations, such as bar charts, line charts, area charts, and tables, to help users quickly understand a team's performance. By including these key statistics in a team performance dashboard, users can gain insights into a team's strengths and weaknesses and make more informed decisions about teams. You've seen this slide before, but we wanted to give a quick refresher as to where the data is coming from and what it looks like. In an earlier lecture, you saw that the Python code uses a mysportsfeeds.com API to retrieve and normalize the data. This process saves team and player statistics as a CSV file to your local computer. So, like how we showed you earlier, you use the CSV file and import that into Power BI. For our team performance dashboard, you'll import the team stats file into Power BI and begin to create your dashboard.
We use My Sports Feeds as our data provider because we have many different projects that require predictable hockey data. However, you can choose a different data source if you want. There are plenty of free hockey data sources out there for you to use. A couple of good sites to check out are Reference Hockey, NHL's website, and HockeyDB, to name a few. Kaggle, a great site if you're looking to learn more about data science, also has hockey data sets. Lastly, if you do use other data sources, you can manually download or export those sources or use other techniques and programming languages to get that data. The point is, don't feel pressured to use a paid provider if you want to keep your budget tight.
When designing an analytics dashboard, the initial steps involve sketching out the layout and creating a wireframe. These steps help in visualizing the dashboard's structure and layout before proceeding with the actual design process. In a business environment, this is very typical of how you start the design process and is also an imperative. This is because it's quicker and more efficient to review a design of the dashboard before you put a lot of time and energy into creating and deploying it into production. While this is more of a hobbyist course, we still want to give you some of the design essentials. Sketching out the layout is a quick and low-fidelity way to capture the initial design ideas. It typically involves using pen and paper or a digital sketching tool to draw a rough representation of the dashboard's components, such as charts, tables, and filters. This step allows you to explore different arrangements and configurations, considering the placement of key elements and the overall visual hierarchy. It's important to note that the sketching phase is meant to be fast and fluid, focusing more on capturing ideas rather than creating a polished design. Once the layout is sketched, the next step is to create a wireframe. Wireframing involves using specialized tools like PowerPoint, Balsamiq, or directly working in Power BI. Wireframes are more refined representations of the dashboard's layout, often including placeholders for specific data visualizations and interactive elements. Wireframes help designers and stakeholders visualize the structure and functionality of the dashboard in a more detailed manner. They serve as a blueprint for the final design, indicating the positioning of different components and providing a clearer sense of how the dashboard will look and function. Creating a wireframe allows you to evaluate the overall flow of the dashboard, assess the effectiveness of the proposed layout, and gather feedback from stakeholders before investing significant time and effort into the actual implementation. It also identifies potential design challenges, so you can make necessary adjustments to improve user experience and data presentation. Overall, the steps of sketching out the layout and creating a wireframe provide a valuable foundation for the design process, enabling designers to visualize and refine the structure and arrangement of the Hockey Stats dashboard before diving into the actual implementation. Here, you can see a super quick and dirty sketch of the team performance dashboard. To do this, we took a blank piece of paper and a pen and sketched out what we thought the dashboard should look like. It shouldn't be too fancy. This took us no longer than a few minutes to sketch. And while rough, it illustrates how you want to lay out visualizations in the dashboard and some hints on what visualizations you want to use. In real-world projects, we find that this is a fun and useful way to generate ideas. But again, it should be quick, fluid, and just get your thoughts on paper or in a design tool. The next stage is the wireframe. This takes your sketch and adds a bit more symmetry to the design. Here, we've used PowerPoint, but you can use any tool you want.
Beyond sketching by hand and using tools like Balsamiq, you can also use PowerPoint to create wireframes. For example, here you can see that we've created a simple structure for the initial dashboard. Note that if you use PowerPoint to create your wireframe, you can also use the wireframe as the background image for your Power BI report. Whatever tool you use to build the wireframe, be sure to build this step into your design process. It will save you time and help you think through your design.
For the next few slides, we're going to explore a few different visualizations and controls, and talk through why we chose a specific visualization. This first visualization is a table, and we chose this for the total point statistic because it's a simple visualization to read. You can create conditional formatting to create a heat map, for example. You can sort the table in ascending or descending order based on points, and you can create interactivity with the other charts on the page. For these reasons, the table is an effective visualization as a starting point for the team performance dashboard. Let's move on to the next visualization. When representing wins versus losses, there are various chart types to consider, two of which are the normal bar chart and the stacked bar chart. Each chart type has its own strengths and considerations. A stacked bar chart is a suitable option when you want to show the composition of wins and losses within specific categories. For instance, you could use the stacked bar chart to display the distribution of wins and losses across different opponents or time periods. The chart would have two stacked bars, with each segment representing wins and losses respectively. The height of each segment indicates the number of wins or losses in the corresponding category. This chart type effectively visualizes the relative proportions of wins and losses within each category, allowing for easy comparison. On the other hand, a normal bar chart is a straightforward option for comparing the total number of wins and losses. It presents separate bars side by side, one for wins and another for losses. The height of each bar corresponds to the total count of wins or losses, making it easy to compare the overall performance. The normal bar chart provides a clear and intuitive representation of the absolute values, without the added complexity of dissecting wins and losses within categories. The choice between a stacked bar chart and a normal bar chart depends on the specific insights you want to convey in your hockey stats dashboard. If you want to emphasize the distribution of wins and losses across different categories, such as opponents or time periods, a stacked bar chart would be more suitable. It allows viewers to assess the relative contribution of wins and losses within each category. However, if the main focus is on comparing the total number of wins and losses, a normal bar chart provides a concise and straightforward visualization. For our team performance dashboard, we chose the stacked bar chart. This is because we wanted a cleaner visualization, and a normal bar chart that has multiple variables it's comparing can sometimes be difficult to interpret. When representing power play percentage, two chart types to consider are the bar chart and the line chart. Here again, each chart type offers distinct advantages and considerations, depending on the insights you want to convey. A bar chart is a suitable option for comparing power play percentages across different teams or time periods. Each bar in the chart represents a specific team or time period, and the height of the bar corresponds to the power play percentage value. The bar chart allows for quick visual comparison of power play percentages, making it easy to identify teams or time periods with higher or lower success rates. This chart type is particularly effective when there are significant differences in power play percentages that need to be highlighted. Also, in Power BI, you can sort bar charts, as well as other charts, in ascending or descending order. So you can quickly visualize those teams that are at the top of the league and those that are at the bottom. On the other hand, a line chart, or area chart, which is a line chart with shading, can be used to visualize the trend of power play percentages over time or across the teams. And while the line chart is optimal for time series data, for example, stocks over time, it's also useful to show values across a finite set of variables. In our case, the power play percentage across all the teams in the NHL. When deciding between a bar chart and a line or area chart for representing power play percentage in a hockey stats dashboard, consider the primary insights you want to communicate. If the focus is on comparing power play percentages across teams or time periods, a bar chart would be more appropriate. However, if the goal is to visualize the trend or changes in power play performance over time, a line chart provides a clearer representation. Here, we chose the area chart, so a shaded line chart. We did this to give the dashboard a bit of difference across the visualizations and still give the user the ability to sort the data if they so choose. The penalty kill percentage has the same option as the power play percentage. So rather than go through the same comparison again, here, again, we chose the area chart for the same reasons we chose it for power play percentage. When representing shots for versus shots against, two chart types to consider are the stacked bar chart and the scatter chart. Again, each chart has its own pros and cons. A stacked bar chart is a suitable option for comparing shots for and shots against across different teams or time periods. Each bar in the chart represents a specific team or time period, with segments within the bar representing shots for and shots against. The height of each segment indicates the number of shots, and the total height of the bar represents the total shots for or shots against. This chart type allows for a visual comparison of shots for and shots against, and the stacked nature of the bars helps understand the relationship between the two variables. It's particularly effective in highlighting differences in shot differentials between teams or over time. On the other hand, a scatter chart can be used to visualize the relationship between shots for and shots against for individual games or teams. Each point in the scatter chart represents a team, with the x-axis representing shots for and the y-axis representing shots against. The scatter plot allows viewers to identify patterns and correlations between shots for and shots against. It can provide insights into offensive and defensive performance, indicating whether teams with higher shots for also tend to have higher shots against or vice versa. Additionally, the scatter chart allows for the identification of outliers or anomalies in shot differentials. While the stacked bar chart gives you a straightforward comparison of shots for versus shots against, here we chose the scatter plot. The reason was we wanted to see how better teams were performing and where they landed on the plot. For example, a team like Carolina Hurricanes has a high shots for and low shots against, so they fall closer to the bottom right of the plot. Teams with higher shots for typically have a higher number of goals. Of course, there are multiple factors here, and if a team also has a lower number of shots against, they likely have a higher percentage of wins or propensity to win. Again, there are multiple factors here, but this starts to get you into looking at relationships across data points. And this is where hockey analyses get very interesting. When representing goals for versus goals against, we were evaluating a similar approach to shots for versus shots against. So here, again, we chose the scatter plot to show the relationship between goals for and goals against. Now that we've walked through the different visualizations, let's go ahead and create the final dashboard. The first step is to import the CSV file into Power BI. You've done this before, but to do this, 1. Open Power BI. 2. Click Get Data, then select Text/CSV and click Connect. 3. Navigate to the CSV file and click Open to load the data into Power BI. 4. Click Load to fully import the data into Power BI. The next step is to create the table for the total points. To do this, 1. Click Table in the Visualizations pane. 2. When the table is added to the main canvas, click it to make it the active control. 3. Expand the data in the Data pane and select ABB and Points. You now have a table with the team's abbreviation as the first column and the total points as the second column. You can optionally add some conditional formatting to the table. For example, to create a heat map style in the points column, select the down arrowhead besides the points column in the visualization pane, select conditional formatting, and then select a color for low and a color for high. This will create a heat map effect for the points column. The next step is to add the wins versus losses stacked bar chart. To do this, 1. Click the 100% stacked column chart control in the visualization pane. 2. When it's added to the main canvas, click it to make it the active control. 3. Drag and drop wins and losses from the data pane to the y-axis in the visualization pane. 4. Drag and drop ABB from the data pane to the x-axis in the visualization pane. This gives you a baseline stacked bar chart with the same height for each bar. The next step is to add the power play percentage and the penalty kill percentage. Because we're using the same area chart for both of these, we'll cover both of them below. To do this, 1. Click the area chart control. 2. Click the newly added control to make it active. 3. Drag and drop ABB in the x-axis field and PP percentage in the y-axis field for the power play percentage chart, and ABB and PK percent for the penalty kill percentage. Note that you can also create the power play percentage first and then copy and paste it on the main canvas and change PP percent for PK percent in the y-axis field. We'll again do the last two charts in one go because they are, again, similar. These are the scatter plots you'll create for the shots for and against and goals for and against. To do this, 1. Click the scatter chart control. 2. Drag and drop ABB onto the visuals field in the visualization pane. 3. Drag and drop the goals for onto the x-axis field and the goals against on the y-axis, or shot attempts against onto the y-axis and shot attempts for onto the x-axis. At this point, you have the substance of your dashboard. That is, you have your key visualizations that make up the dashboard. However, you'll still want to position them, edit the titles, background colors, and so on to improve the look and feel of your dashboard. To edit each of the visualizations, you do this in the Format Your Visual option in the Visualization pane. Here, you can edit the titles, text color, background colors, etc. You can also click the visualizations and add trend or constant lines. To do this, click the visual, and then click the Add Further Analyses to your visual in the Visualization pane, and select the option you want to add. After you format your dashboard, you will have your first complete team performance dashboard.
If you remember, I mentioned that you can create a background for your Power BI report in PowerPoint. Let's close this lecture by doing a super quick walkthrough on how to do this. First, open PowerPoint. Then, format the slide background and add some shapes. You can even add the title text here if you're confident you won't need to change the titles in Power BI. Then, save the slide as an image file. You can then import the image file into Power BI, adjust the fit, and then add your controls to the canvas. This design was super quick and dirty. If you spend a bit more time in PowerPoint, you can create great-looking designs for your dashboards.
You're almost near the end of the course, so congratulations for getting this far. In the next section of this course, we'll be doing a brief overview of how to refresh or update the dashboard. So let's get going.